So to be ready for this linear programming worksheet, I want to make sure that you understand some basics. Like, for example, if I graphed this line, I know you know how to graph a line by now. That has a negative slope. Let's say that that line had been negative x plus 5. If I said less than, which way would I shade? Say it if you know it. Down, under it. Okay. Now, if this was about making DVD players and, what's something else that people still make? Starlink receivers. Starlink is this kind of internet you can get from satellites that are orbiting the Earth. So even if you're in the middle of nowhere, you can get the internet. I just ordered one. I should be able to be telling you more about that soon. But the nice thing about it is you can take it on trips with you, and we go to a lot of national parks. And so if you take this little receiver with you and set it up outside your car, you have super high-speed internet anywhere, even in like the middle of the desert. All right, so back to, you've got two different things here that you could make. You could make a whole bunch of DVD players, but do you get, since this is at like, let's say it's at 5,0, you're making 5 DVD players, but 0 Starlinks. And up here, you're making 5 Starlinks, because we started at 5, but you're making 0 DVD players. All right, so this is about making things. Now, if I said this, I think you would agree. You can't make negative DVD players. You can only make 0 of them or more. That's a line that looks like this. Do you get how that's a reasonable constraint to a company? You can't do negatives. And so the same thing on the Starlink, or if I did the other one first, whatever. The same thing the other way. You can't make negative numbers of them. And do you see those all kind of shaded so that this region is the region where it's possible for the company to make that many of them? So if you're in here, again, this is a test type question. What does it mean to be in here? It means that it is a possible number of DVD players and Starlinks that you could make as a company that day. Whereas if you're out here, that is not feasible. So if that was at, let's say, 8, 4, you can't make that many. This point is not shaded in because this point out here is too big. You can't make that many. All right, so the points that are inside there are feasible. All right, that alone is a lot. Like, I've given you a lot of information here. But there's more. Then we start talking about profit. Now, a company is in business because they want to make profit. And the profit amount, we're just going to use a nice, clean number of, let's say when they make a DVD player, since those have been around forever and they're fairly cheap, they don't make too much profit. Let's say they only make $20 of profit for each DVD player they make. And on Starlink, since that's a fairly new product and it's pretty popular right now, they have like literally 1 million people have signed up for this service already. And so if they charge like $600 for this stuff to get it set up, 600 times a million is $600 million they brought in from this. Anyway, so let's say on the Starlinks that they make far more profit. Let's say they make $100 profit on each one they sell. Okay, so far I'm just talking to you about what these problems are like. Do you think you could have done the graph? Could you graph that? Could you have shaded it in the right direction? Do you understand the part where you can't make negative numbers of things, and so you gotta shade up from 0? You gotta stay inside of 0? I'm getting more blank looks on that one. Do you get, I cannot make that number of DVD players because it's negative. The Starlink number would be a negative number. You can't have a negative number of Starlinks. All right, so you couldn't have a dot down there. So we shaded upwards and made that little triangle. That little triangle has a name. It's called the feasible region. If you've never heard the word feasible before, it means that's possible. Like if I said, I am going to bring $100 to school tomorrow. I think for a lot of you that's feasible. You could probably do that. You could probably ask mom or dad, dig in the couch cushions, maybe go to the bank. You could get $100. But if I said, bring $10 million with you to school tomorrow, that's not feasible. Feasible means possible, okay? So these things that are inside here are feasible. You could choose them. Now, here's the last piece of that. The corners are always the ones that give you the most profit. People have done these problems enough to know that of all these choices you could pick, any of these things in here are feasible. The ones that would probably make you the most profit would be at a corner. That's one of your corners. That corner would be at 5, 0. And your other corner is up there. So we only make you test the corners for how much profit you would get. See how these problems get intense? So you're going to test this corner and this corner, and tell me logically why you don't need to test 0, 0 for how much profit you're going to make. Don't you know how much profit you're going to make already? 0. So there's no reason to test 0, 0 to see how much profit you make. Now, if you've been kind of zoning out, this is the part where you don't have to copy all this down. What I need you to do is to make a profit list over here. We're going to write vertex. Please write this down. And profit right next to each other. And your job is to figure out which vertex makes you the most profit. Welcome. Have a seat. Late enough, I do have to mark you absent today. All right. Make sure somebody calls you in and you'll be fine. All right, so the vertex here is 0, 5. The other vertex is 5, 0. And can't you tell from where I put them which one is X and which one is Y? So, figure out how much profit that would be. Figure out how much profit that would be. Again, this is the X and this is the Y in every single point you ever graph ever. And you can use a calculator if you want to. But how much would the company make if they did 0 and 5? And how much profit would they make if they did 5 and 0? Take a second, use the calculator. If you need to borrow one from me, you can. You can use your iPad's calculator if you want. And figure out how much profit you get with 0, 5. And the other way is 5, 0. Okay, so the two profit amounts are $100 for the Y's, and DVDs are the X's, and they're $20 a profit. So here, X has 0, so 0 from the X units, 5 from the Y's, that means $500. You get how that happened? How many of you had $500 for that one? Okay, if you didn't understand that, get how there's 5 Y's. Get how the profit was $100 each for the Y's. That's how you should have got the $500. All right, over here, we got 5 X's. X's are $20 each. 5 times 20, $100. Why aren't you adding anything for the Y's? Because there was 0 Y's in that scenario. Do you get as a company, this option is way more profitable. $500 is more profitable than $100, and therefore that wins. That was the best spot, that one. But now I want you to think as a real business person. Are there any scenarios where it would be stupid to take the thing that makes the most profit? Can you think of something that, like, even though it makes the most profit, you probably shouldn't do that? Some thoughts? All right, let me give you this example. Apple. Do you get that Apple has a product that they make the most profit on? There's going to be one profit that they make the most profit on. Should they quit selling everything else and just sell that? No, that'd be dumb. Because maybe having a whole bunch of products gets people to like your general ecosystem of products. And so maybe they get sucked in because they like the iPhone, but then once they've got the iPhone, they're like, ooh, I really like this music that I can get through my iPhone. And then all of a sudden they're paying for your music service. And then because they got the iPhone, the next time they buy a computer, they're like, maybe I should buy a Mac because they're like the Apple system. And all of a sudden you got people buying Macs because they bought the iPhone. So my point is, I'm just trying to be smart about this. Just because this has the most profit doesn't necessarily mean in the real world that you would just do that and say, well, we're going to quit making DVD players because we make more money on Starlink. Again, this is an oversimplified example because there's only two products. But in the real world, you do have constraints. If you are like selling cars, you can't just say, well, next year we're going to sell 50 million cars because we're making profit on them. Well, maybe there isn't enough people to buy 50 million cars. So it's much more complicated in the real world, but they do have to make these kinds of decisions. I know, for instance, on electric cars, they only have so many batteries. And so, for instance, if they say, we're going to go whole hog on semis, because semis are awesome. Their semi is a really sweet thing. They're selling tons of them. They make lots of profit on them. But if they put all their batteries into semis, they wouldn't have any batteries left to put in the cars because they only have so many batteries. So they kind of have to figure out how to allocate that. All right, so that's what the real world application of this is. All right, so now you have two problems on this worksheet. I want to work through one of them with you, and then the other one I want you to do at home. Okay, so you can see how these kind of work. This is a big chunk of your test. It's not that you have to solve one of these problems to get 5%. It's more like one problem like this is divided up and represents maybe 3 parts of your test. So maybe you have a chance to get this part right for 5% and that part right for 5%. So this is like, if you want an A or a B, you really have to understand these. And on the first time we do it, you might not. But the test isn't Monday. All right, so we still have a chance to review here coming up. The test is not for a few days. Okay, so that first one, I want to do the one that says the case. So find the one that starts with the case of the case company. Do you get that there are people that sell iPhone cases? And in there, and then they don't work for Apple. They just want to make their own cases for Apple products. And so that's what I patterned the problem after, because I know that online you can go, and I bet you there's 50 different companies that sell cases for iPhones. And they know exactly how big they are, and so they make the case just right, fit it, and then they can brand it themselves. And it probably only costs them 50 cents to make the case, but they can sell it for a lot of money. And so, bottom line is they have to try to sell people their case, and they're going to make some money on these cases. All right, so let's read the case of the case company. Everybody take a second and just read through it once. Just read through it. Try to get a feeling for what's happening with this case company, how much money they make, what their constraints are, which means restrictions. So I really appreciate you giving it your best shot here with me. I made this last night. You're my first class. Okay, so it's possible that there could be a mistake in here. I did double check it, and I think I got it all logical and right. So the first thing I want you to underline is what's X and what's Y. Please underline right here or circle. iPhone cases is going to be X. iPad cases is going to be Y. Got that? It's critical to know which ones are which. So the iPhone is X, and then do you know which of these that is? If you don't know which one's which, it's kind of a big deal. Figure out which one's X and write iPhone by the X and iPad by the Y. Are you writing this? iPhone is by the X, so this is iPhone down here. iPad, and it's cases, but we don't have to write that. That's fine. Okay, so far we got it set up. We know what our X is, we know what our Y is. Now, can you write the equation? We practiced that yesterday. Can you write the equation for the factory hours constraint? That means we only have so many hours that we can make these things. And so for the week, we have 34 hours that we can work in the factory. It's all the time we have in the factory that we've hired people to come in and work. Okay, so there's obviously a 34 in your equation, duh. And your answer is kind of like this, but it's not quite that simple. Write down what you think it is. Two for each iPad, plus it takes one for each. Wait.
iPhone is 2, iPad 1.
Thank you. One for each. So the first one was iPhone, the second one's iPad. And that should be equal to 34, and then I'm really close, but I'm wrong. Can somebody tell me why? Yes.
Less than 93?
Yes. And what was the key word? Well, there was two. The first one said, cannot exceed. You're supposed to know if something says cannot exceed, that means it can't go over 34. That means it could be less than 34. All right. Another clue that this was not an equals is it said inequality. It means it's not supposed to be an equals. All right, now if I was going to graph this, which you will eventually, do you get you'd want to solve it for y? One of the top 3 skills for this test is you got to be able to solve for y. So everybody take a second, solve for y. Zane, what did you do to both sides? Good. Can you read me the final equation in the right order? That's a less than.
Oh, less than.
Because it kind of looks like an L.
Yeah. Negative 2x.
Nice. You knew to put the negative 2x first. Now, do you get... One of the reasons I had to rewrite this problem is because my graph paper only went to 36. And so I was originally going to do 40 hours in a week, you know, because there is typical 40 work hours in a week. But I had to stick and stay under 36 because the graph paper was only that big. And it's actually kind of hard to find graph paper online. So I thought, well, maybe there's less work hours available because, I don't know, maybe people have breaks and stuff out of their 40 hours. And so we'd say there's 34 hours. All right. Now, if I was going to graph this, let's do that later. I know you could do it now, but let's finish writing our equations. Here's the next equation. iPhone case production limit. The company can produce at most 12 iPhones. Figure out how to write an equation for that. It is simple. But if you don't have that equation, you can't finish the problem. At most 12 iPhone. So kind of ask yourself, does that mean that you can do more than 12? Or does that mean that you want to be less than 12? And then which one is iPhones? Did you realize it was X? And that it's supposed to say less than or equal to 12? Raise your hand if you had X is less than or equal to 12. Good, okay. Catching on, this is good. Then that's the second thing we're going to graph in a minute. But there's one more thing, and this is important. It said, don't forget the non-negative constraints. Do you get that iPhones You can't produce a negative a number of iPhones. The lowest number of iPhones you could produce, or iPhone cases in this case, is 0. So there's an equation for that. Caden, what do you think the equation would be about saying you can't go below 0?
Something less than or equal.
Let's say X.
X is less than or equal to 0.
You just said it can go below 0.
Oh.
I think you didn't mean that. There we go. See, once you actually write it, then you can start analyzing it and go, oh, wait a minute, it's got to be this way. Now, would you agree that the X things that we're producing, which, by the way, are iPhone cases, have to be bigger or equal to 0? That's one of those equations. And then, of course, the other one's going to be logically Y has to be greater or equal to 0. All right, one of the weird things about math is that the y-axis is where x is 0. So I need a line that runs right there but doesn't cover up my numbers. And it's supposed to stay greater than 0. And now I'm going to do my x line, which again, I don't want to cover up my numbers. And it's got to stay greater than 0. It's forcing me up into the positive numbers or 0. Now graph these two, that one and this one. And let's see what shape this thing makes. It'll be like a little trapezoid-y thing that'll have corners. The corners are called vertexes, and that'll be, one of those will give us the most profit. So please graph this line. Hint, it starts at 34, and it has a slope of going down 2 and over 1. If you need a pencil, you can borrow one from me. Okay, so here's how it should have looked. This one started at 34 and kept going down 1 over 1, down 1 over 1. And if it starts at 34 and, oh wait, down 2 over 1, see, down 2 over 1. Now you're not going to have to watch me do all of that because I'm going to use math. And I'm going to go, if I do that, will I hit the 34 down here? No, that wouldn't make any sense. That would be if I did down 1 over 1. It'll hit half of 34, which would be 17. So it would hit there. And now I can just draw a straight line that goes between those two. That might be the hardest part. Okay, let's see if I do have a straight line drawer. It's right there. And I'd say this might be like a 70-degree angle. How am I supposed to know what degree that is? I suppose I could probably figure it out math-wise, but that's ridiculous. Okay, my straight line drawer is not amazing on this thing. It'll draw me a straight line, but you have to know exactly what angle you want. So, okay, so much for that. I'm going to take off the straight line drawer and just freehand it. I know that's off, but you guys will be much, much straighter. Okay. I wish I had notability sometimes, but this explain everything is good for recording. So, okay, now I have a x is less than or equal to 12 line. So here's 12. And again, my line is slightly off. Can you guys tell me from yours, which is much more accurate than mine, one of the reasons that I gave you paper, okay? Can you tell me, where did those two cross? Because that's a vertex, and it's a key point.
12, 10.
Can anybody verify 12, 10?
Yes.
Excellent. Okay. Then, if I shade the correct way, which is less than is this way on a vertical line. Did you know that? Less than are the numbers that are smaller on the left, so you shade that way. And then here's the way you shade on this one. And my final answer is, I'm going to shade it in yellow. that shape. The most profit will come from the vertexes. One of them is 1210. One of them's down here at, I think it's, can anybody verify 12.0? That corner down there?
Yes.
Okay, thank you. And then, well, the last corner is pretty easy because it's where we started, right up there at 34. So that's 0, 34. Do you remember me telling you that the 0, 0 was kind of useless to test because you're not doing anything, so of course you're not making any profit? Okay, so we just have to test these three. So write them down as the vertices, 0, 34, 12, 10, and 12, 0. Once again, you can use logic. You've got a brain. You can go, wait, there's no way that 12.0 is going to be as good as 12.10 because 12.10 has profit from 12 of the one and 10 of the other. So I'm ruling that one out. I know it's between these two, but I don't know which one is actually going to give me more profit. So that's where I got to look at the very beginning of the problem where it said how much profit I made. Profit of $15. Let's write the equation for that. P profit, write this down. P 15 for each X plus you're gonna make 3 for each Y. 15 for each X, 3 for each Y. Now you use that.
No.
No?
Y is iPad.
iPhone cases are 15.
No, they're free each.
Okay, I want you to read this with me. For each iPhone case they sell, they make a profit of 15. iPhones was 15. iPhones is X, so I actually think I did it right. I totally get, I make mistakes. I want you to correct me, but I think I'm right this time. And then the iPads are 3. Okay, so I think I did it right. So then you're going to use this and figure out how much profit do you make here and here. And one of those two is the final answer. Holy crap, we have to do this on the test? It'll be separated out into different pieces. So you won't have to be able to pull off all of that to get like 5% on the test. It'll be like, do you know how to write a profit function? That might be worth some points. Do you know how to figure out which corner gives you the most profit? That might be worth 5%. Do you know how to graph this thing and show me where the corners are? That might be worth 5%. So these skills are all broken out on the test. I just don't want you to think that you have to pull off this perfectly to get a good score on your test. But it's like little separate skills. Now, I know that the other one that I made for you on the back side of this worksheet is doable. It is not exactly the same, but it's very similar and it's very doable. So if you actually want a shot at an A on this test, you should take that seriously. I'm going to post the key for it and see how much of this you got and see how much of this you don't got. If you don't know how to write the equations, ask me. If you don't know how to write the profit thing, like this thing I'm about to show you right here, ask me. I'll help you. Okay, so the 0, 34 has to go in here now. So I'm going to write out my profit. Profit is 15 for each X plus 3 for each Y. And in this case, we have only 34 Ys and 0 of the X's. So 0 here, 34 there. If you knew that it was 3 times 34, which would be 90, 102. Anybody have 102 before I said it? Sweet. This other one is 15 for each X plus 3 for each Y. And you stick in your X and your Y from this point and figure it out. That's on you. All right. Now, I wish I could just make it easy for you. But these, you're going to have to struggle through it yourself, and you're going to have to get stuck, and you're going to have to ask the kid next to you or me. Some of you already got it, I know. I watched, I know some of you were already literally finished with the other problem on the backside. So this is very doable, but if you get stuck, you gotta ask. All right, that's all I got for you for today. That was called linear programming. Literally, one of the hardest things you'll learn this year.